Okay, so we are going to pick up now on the second video of our Chapter 1 lecture. So this is going to include where we start talking about ratios and density. So I am going to scroll over here to this slide that talks about data. And all I really want to talk about as far as this particular slide is concerned is that whenever we take data, we are going to measure something, and it could be various things, but we're going to end up with some kind of number and some kind of unit, kind of like this. There's a number here, and there's a unit. And we're going to do a lab where we have to measure different cubes and do ratios. So this will make a lot more sense when we actually do this lab. But I want to go to this slide to kind of show you what's going on as far as ratios. So whenever we talk about a cube, we might need to talk about area of that cube, or we might need to talk about the volume of that cube. And so when we do the area, if we did like the area of the floor, we would do length times width, and we might measure the area of the floor in square footage. Well, so that's kind of like this number right there. See how it's inches squared? So when we do the area of a cube, we just do length times width, but something different with a cube is we have to multiply it by the number of sides. Well, there's 6 sides to a cube. So if we say, for instance, that the cube is 1 inch on each side, we would say 1 inch times 1 inch times 6. So it ends up being 6 inches squared. So that's where this number comes in right here. Now, if you remember doing volume in math class, you remember that volume is equal to length times width times height. So again, if you have a cube and it has 1 inch sides, you would have 1 inch times 1 inch times 1 inch, which just equals 1 inches cubed. Okay, so this squared and this cubed tells you whether or not you were talking about area or volume. So if we do the ratio of the area to volume, then we simply take 6 divided by 1, which is just 6. That's our ratio. And then it goes on and it shows if you had like 2 inch sides or if you had 3 inch sides, and you can see how it starts to change those numbers, and actually how the ratio starts to decrease. Okay, so why are we talking about ratios? Because this is going to get us into density. And density is basically a ratio of just mass per unit of volume. And so this is your equation for density. And density has this weird looking symbol right there that kind of covered it up. Here we go. So density has this kind of weird looking symbol, not the right thing, there we go, known as a rho. And it looks kind of like this funny P. And you need to know that that symbol right there means density. You do not have to memorize this equation. I will give you that. But you need to know that density involves mass and volume. Okay? And you can rearrange this equation in different ways. So what is density? Density is pretty cool. It's just a physical property that describes a certain material. So when you did that computer lab, you should have started to realize that, for instance, when you did the density of that wood block in the water, that no matter what you did to the mass, the volume would change too, because it always had to be the same density. Same with the aluminum, same with ice. You know, everything has its own density. So like if you go over here and look at gold, for instance, gold has a density of 19.3 grams per centimeter cubed. That's what its density is. So we should be able to take a piece of gold, no matter what size it is, we should be able to weigh it and get its mass in grams. We should be able to do some kind of water displacement. You guys should know what that is now after doing that computer lab and figuring out what that is as far as volume. And then you should be able to figure out what its density is, and it should be very close to 19.3. Okay, so I want to flip to my notes really quick because, oh, how do I do this? Sorry, it's all kind of new. All right, so we said that density was equal to mass divided by volume. So I wanted to show you this little trick if you didn't see it in class. This is this triangle. If you have an equation that has 3 variables in it, you can always do this triangle. And you really just kind of set it up the same way that it is in the equation. So density is over here on the left, so you put it over here on the left. Mass is sort of at the top over here of this fraction, so it has to be on the top, and here's sort of like that fraction line right there. And then here's volume. So what's kind of cool about this is if you were wanting to solve for something else, you wouldn't have to do a whole bunch of algebra. If I wanted to, I'm going to show you the algebra really quick. If I wanted to solve for volume here, see how this equation is in a fraction? Well, that's no good. So we want to get rid of that fraction. So the first thing that we would do is we'd want to just get everything linear. And the way to do that is we just multiply by that denominator. You cancel that and you end up with volume times density equals mass. Well, that doesn't solve for volume, that solves for mass. So how do you solve for volume now? Well, you would just divide both sides by density. And that cancels density out, and so now you have volume equals mass divided by density. So if you look over here at this triangle, there's a much simpler way. If you are wanting to solve for volume, take your finger and cover up that V and look at the equation that you have now. You have mass divided by density, which is the same thing that we have up here. If you wanted to solve for mass, put your finger over that M. And then look how these are side by side. Two things are side by side, then they're multiplied, right? So then mass is, like if you look up here, going back to this equation, mass was equal to volume times density. So this is just a simpler way to figure that without actually having to do any algebra. Okay, so you're going to have to do, or you should have done actually, quite a bit of work on density already as far as the homework was concerned. So if you haven't done that homework, you need to do that homework as soon as possible, and that might help you a little bit. Okay, and back to the PowerPoint. All right, so now we're looking at symbols and equations, and I've talked about symbols, like for instance, with density. You need to be familiar with that symbol rho, and you need to know that that means density. Okay, and then equations might have some of these symbols in them, and they are going to describe properties and concepts, and they're going to show relationships between things. Like for instance, density shows us that it has a relationship between mass divided by volume, which was obvious because when we actually solve for density, it gives us units of grams per centimeter cubed. So that makes sense that it has a relationship between mass and volume. Okay, so if we're looking at symbols for equations, okay, this is showing us how things can be proportional to one another, or how they could be maybe inversely proportional. So for instance, if you have something that is linear, like A is linear and it's proportional to B over here, okay? That means that if A increases, then B is going to increase. If A decreases, then B is going to decrease. So I'm going to kind of skip ahead to a different chapter because I just really like this analogy. But let's say, for instance, I'm really a terrible artist when I have to do it on the spot. Some of my students would say I'm just terrible all the time, but I'm really not. If I, this is terrible, this is absolutely terrible. This is like a person on a bicycle. Yeah, I know, it doesn't look anything like a bicycle. But let's just say it did, for example. And let's say that if that particular person applied a lot of force to those pedals, would it go faster? Yeah. So that gives us Newton's second law, which we haven't gotten to yet. But if we apply a lot of force to something, we're going to go faster. We're going to accelerate. Okay? So that is proportional. That is directly proportional to one another. Okay? But if I go and let's see, if I want to know, like, the acceleration of something, I've just rearranged this equation. So acceleration is force divided by mass. If I apply the same force that I was before, but I add mass to it, I'm applying the same force as I was before, but I'm applying more mass. Like somebody else has jumped on the bike here. Somehow. Somebody else has jumped on this bike, and so now there's more mass. Do you think that you accelerate as fast as you were before? No, because they are inversely proportional, like this guy right here. So as this says as A decreases, B increases. Okay? Or if you said as A increases, B would decrease. So, okay. All right, I think I'm going to stop there, and I will add another video for the remainder